South of Moscow, north of Turkey, scientists in the Republic of Georgia may hold our last defense against the superbugs, against the advance of antibiotic-resistant bacteria. From this sewage comes a medicine made from a virus, the virus that cures.
How far away are we from a return to people dying from sore throats?
At a press conference on May the 23rd, 1997, scientists finally acknowledged the arrival of the untreatable bacteria they feared for years.
It sounds as though we finally discovered in the wild the dreaded superbug we were all fearing. Is that right?
Yes, in a sense it is a superbug, yes.
Today, superbugs look triumphant. They are bacteria that resist our antibiotics. The drugs which have kept us safe for 50 years are beginning to fail.
This is a serious situation. Over the last 5 years, we've clearly seen a change in our ability to treat what should have been easily treatable infections, because the bacteria are developing the ability to resist our antibiotics.
And the more antibiotics we use, the more resistant bacteria become. Every year, more than 5 million people die from infections that don't respond to antibiotics. These horrifying bacteria have colonized hundreds of hospitals in Britain and thousands in the USA. And things are going to get worse. Staphylococcus is one of the most dangerous of all bacteria. One by one, it has beaten all our best antibiotics. Until now, only one is left: vancomycin.
If we develop a staphylococci that's resistant to all of our currently available antibiotics, including vancomycin, then we're in very serious trouble from a medical standpoint.
What Glenn Morris feared has now happened. This year, Japanese doctors saw the world's first case of infection with vancomycin-resistant staphylococcus. A baby boy who was in hospital for major heart surgery became infected. When antibiotics failed, doctors had to pour strong disinfectants directly into the wound on his chest.
I was very much shocked because the outcome of that bacteria infection was quite hideous. The patient suffered a lot.
These terrible bacteria will inevitably spread. And when they do, being in hospital even for minor surgery, for a hip operation or to have a baby, could be lethal. If even the smallest wound became infected, the bacteria would most probably kill you. They threaten the future of modern medicine.
Some more patients will die.
I'm not quite sure that people have quite realized what might be at stake.
It'll be very hard to do the major surgery that we've got used to.
The transplants that we do, organ transplants, cancer chemotherapy, all are dependent on our ability to kill off bacteria, which may infect wounds or may infect patients. We'll lose all that.
This appalling situation has been predicted for so many years that it's hard to understand why no new drugs have been developed to save us.
Pharmaceutical companies should have known this situation will come. But they thought that was not profitable 10 years ago. Now it is profitable, but it is too late. They should have prepared it 10 years ago.
Even today, drug companies don't promise a new class of antibiotics for at least 10 years, and they may never discover one. They have already exhausted traditional chemistry and computer drug design. Today, they analyze the genes of the bacteria themselves, hoping to uncover new ways of attack. But the frightening truth is that no fundamentally new antibiotic has been discovered for more than 30 years.
One begins to worry that indeed we are moving into what some people have called a post-antibiotic era, into a time when our ability to treat virtually any infection with a powerful antibiotic is going to be over.
This is an alarming prospect. But there is one thing that kills even the most resistant bacteria. Unknown to the rest of the world, this magic remedy is cherished in one small country in the heart of the Caucasus Mountains. This is the Central Hospital of the Republic of Georgia, a former Soviet state. Here, as everywhere, the sickest patients are in the intensive care unit. These men are recovering from serious surgery. They are weak and vulnerable, and would probably die if they caught any infection. The doctors here know that this ward has a problem. It has become the breeding ground for particularly nasty bacteria, which they suspect are resistant to all the antibiotics they have. They're taking samples from every surface in the ward. They have to find out exactly what they're up against.
These are samples which we took in hospital 2 days ago. And these are strains which we isolated from the samples. Some of them are Staphylococcus strains.
Multi-resistant Staphylococcus, one of the most lethal antibiotic-resistant bacteria. Anywhere else in the world, this would be a death sentence. But here in Georgia, the doctors aren't too worried because they have an answer. A unique medicine that still works on antibiotic-resistant infections. The same amazing potion is used to treat both the patients and the ward. It has a remarkable effect on bacteria. Both these flasks contain bacteria, but a few drops of the Georgian medicine have been added to the one on the right, and it has a magical effect. The cloudiness is caused by a thick broth of bacteria, but the right-hand flask is clear, because the bacteria have all been killed. This astonishing effect is caused by something we usually fear. A virus, and the virus comes from sewage.
Я помню, это я увидел 51 лет тому назад, когда я пришел в институт. Первые опыты, которые меня заставили сделать, было именно это. Вот взял я культуру и туда добавил я фильтрат сточной воды. Вот сточная вода, обыкновенная, канализационная вода, так?
В принципе, да, я помню, это было очень давно, когда я еще была студенткой. Это вызывает, конечно, впервые большой восторг. А постепенно потом, конечно, к этому мы уже привыкаем, это уже обычная наша работа.
The first man to spot the potential of this effect was an irascible French-Canadian called Félix Derel. In 1917, he suggested that the viruses which killed bacteria in bottles could also be used to treat disease. An ardent communist, Derel was enticed to Russia by Stalin, who wanted this magic medicine for his army. And in the Finnish War of the 30s, and even in World War II, it was used to protect the Red Army from the dysentery and gangrene that plagued the battlefield. With Stalin's blessing, Derel founded an institute in Tbilisi, the capital of Georgia, that was dedicated to the study of these magical viruses and the way they cure infections. Derel named these healing viruses bacteriophage, which means bacteria eaters, and there is a phage to kill every kind of bacteria. Just as bacteria attack people, these tiny viruses attack them, and they're found wherever bacteria thrive, most often in sewage. Here they are too small to be seen, but the phage are killing off the bacteria, one by one. Phage have an extraordinary structure. Their bulk is a head in which their genes are stored. They have 6 legs or filaments which attach them to the bacteria, and a tail that works like a hypodermic syringe to infect it with their genes. Inside the bacteria, the phage viruses grow and multiply. Sometimes as many as 5,000 grow in a single cell. When the new phage burst out, they kill the bacteria. And then each goes on to find another victim.
Я их очень люблю. Дело в том, что это область, которая каждый день дает тебе что-то новое. Снимки, все эти снимки сделаны мной. Так что я увлекался электронным микроскопом, пока мне позволяло зрение. Стафилококковый бактериофаг. Бактериофаги сальмонелла. Это бактериофаг псевдомонас аэрогеноза. Это фаги дизентерийные. Это фаги тоже псевдомонас аэрогеноза. Вот здесь. Это дизентерийные бактериофаги. Это, например, стрептококковые бактериофаги. Они совершенно различные, совершенно отличаются друг от друга.
Факт специфичен, да, и эта специфичность выражается в том, что каждый фаг имеет свой хозяин. Он размножается именно на этом микробе. Поэтому мы говорим стафилококковый фаг, что он именно против стафилококка, размножается только на стафилококке.
Being specific makes phage tricky to work with. It means that good treatment depends on a very precise diagnosis, which takes time and money. Over the years, the Institute trained specialists to find phage, grow them, and turn them into medicine. In the 1970s, when antibiotic-resistant bacteria became a serious problem in Soviet hospitals, phage became the savior.
И поэтому издал приказ, чтобы все штаммы бактериальные, которые на месте оказываются, допустим, устойчивыми, пересылали в институт, который готовит этот препарат. И вот поэтому мы получали такое количество штаммов. Это была очень сложная организация, но все это распределение, использование было централизовано.
The centralized Soviet system was ideal for the labor-intensive work needed to make phage effective. Together, communism, phage, and the Institute thrived. Phage medicine had its heyday in the 1980s. It was manufactured in factories across the Soviet Union and here in the Tbilisi Institute. At that time, Temuraz Chanishvili and Amiran Meypariani ran the institute.
Раз, два, три, 4 реактора. 4 реактора по 500 литров каждый. Каждый по 500 литров. И представьте себе, что вы помните,
еще приходилось
иногда и дополнительно принимать заказы.
2,5 тонны в день. И потом готовили таблетки уже. Таблетки во флаконах. Это мы производили для всего Советского Союза.
Не только дизентерийные, и сальмонеллезные фаги готовили.
Энтеральные вообще, энтеральных инфекций.
Для кишечных инфекций. Это наш профиль, это наш хлеб. Это мы посвятили всю свою жизнь проблеме бактериофага. Вот что я могу сказать. А перспектива у бактериофага огромная.
There is no question that phage medicine can be extremely effective.
Не могла я никак его вылечить. Потом мне сказали, чтобы я проверила горло и нос. И когда проверили, у него обнаружилось стафилококк. И я пошла в бактериофаг, дали мне фаг. Но через год все прошло. А фаг – это очень хорошая вещь.
Но эта бактериофага против дизентерии, по-моему, да? Это против дизентерии.
Тестофаг,
Да, биофаг, это против дизентерии.
Против тоже.
Клизму делают, это фага. Правильно?
Да, правильно.
Клизму делают, да.
Today, when people in Georgia get an infection, sometimes they take antibiotics, but often their doctors prescribe phage. This pharmacy is in the grounds of the Tbilisi Institute. Every day, people who choose to use phage rather than antibiotics come here to have their infections analyzed and to pick up prescriptions for medicines, tablets, and creams made of phage. They rub the healing viruses into their wounds, drink them for a bad stomach, or swill to cure a gum infection. And every day in the hospital, these viruses are used to save lives. This woman developed gangrene in a wound on her thumb. 5 days ago, the doctors cut away most of the infected tissue. The rest they treated with phage.
It is ultrasound, and it pushes phage in the deeply in tissues.
If the resistant bacteria rife in the hospital got into this woman's wound, they would cause blood poisoning that would kill her. Phage does not work well in the bloodstream. Being a virus, it's fought off by the immune system. But the surgeons make sure infection doesn't take hold in the first place by using phage to sterilize the room and equipment as well as the wound.
We think that the phage which was used during the first operation, it's helped the wound to be in such good condition.
Phage works wonders in Georgia, and given the chance, it could do the same everywhere. A unique library of phage medicine is held in Tbilisi. It's a national treasure preserved by the painstaking care of the Institute's scientists. It was built up over the 50 years when problem bacteria were sent here from all across the Soviet Union. Phages were found to fight every new infection, and then they and the bacteria they killed were stored separately for future research. There are phages here to fight hundreds of different infectious diseases. Some are even originals from the 1940s. It's the biggest collection of phage medicine in the world.
Здесь у нас уникальные штаммы, микроорганизмы. Значит, здесь хранятся культуры почти со всего мира. Их сохранение, почему нам нужно, чтобы мы хранили бы их? Потому что они используются для размножения бактериофагов.
All bacteria have to be fed. These particular strains eat meat. In the bottom of each test tube is a small piece of liver, which will keep the bacteria going for about 6 months.
Это самое страшное, что они вызывают, это гангрену. У нас есть штаммы ботулинус. Это вызывает тяжелое отравление. Настолько тяжелые, что эти штаммы используют для создания бактериологического оружия.
Целая коллекция анаэробных фагов. Первый это перфлингенс фаг, самый распространенный. Путрификус фаг. Да, все они музейные.
Это не только фаги уникальные, но и форма. Форма ампул тоже. Сейчас, наверное, нигде вы не увидите все это. Настолько интересная форма.
Phage therapy has been so successful here for so long that it's hard to understand why in the West we've never even heard of it.
Даже в Советском Союзе, в институте хирургии, в хирургическом центре в Москве, я делал доклад, я им объяснял, что то. Единственный вопрос, который мне задали, было, если это так хорошо, почему не используют в Америке?
To scientists like Dr. Chanishvili, it seems incredible that this medicine, once used daily right across the Soviet Union, has been ignored by the West. but the reasons are woven tightly into history. In Britain today, very few people know anything about phage therapy, but those that do are clear about how it became discredited in the West in the 1930s.
Some of the claims that were made for some of these bacteriophages which are isolated were, quite frankly, totally balmy. There was one commercial preparation, for example, called Bacteriophagos, which supposedly had miraculous powers against both herpes infections and eczema, which is totally impossible to believe.
Treating things like herpes, which is known now to be a viral infection, urticaria, which is an allergic reaction, and a whole variety of other conditions, including gallstones, which they couldn't possibly work for.
These claims were not fraudulent so much as uninformed. In fact, a lack of understanding plagued most phage work done round the world in the early days. In India, in 1935, even the British Army tried it out on the local population during a cholera epidemic.
It has to be said that some of the clinical trials that were carried out were exceedingly poor quality. For example, some of the early work on choleraphage in the 1920s and the 30s, there were no control groups whatsoever, so it was impossible to see whether the phage had worked. And some of the trials consisted merely in pouring bacteriophage down drinking wells in a village and see whether it had any effect, with no understanding of dose or a good understanding of the mechanisms whereby bacteria produced the diseases.
I think some of the problems with the early studies, though, is that they didn't necessarily select the best phages for the job. They didn't necessarily check that the organism that was causing the diarrhea was the organism that was sensitive to the phage.
By 1941, phage was still thought too unreliable to be useful by researchers in the West. And when powerful antibiotics arrived a few years later, phage was quickly forgotten. Meanwhile, unknown to the outside world, the Georgian scientists went on to do their best work, thorough medical trials of phage under rigorous conditions. But it made little difference to phage's poor reputation abroad.
Bacteriophage work that has been going on in Russia, specifically in Tbilisi, has been going on for many, many years. I'm a little bit concerned about it, in that very little of it has been published in the West.
Research is only considered respectable in the West if it's been published in a well-known scientific journal. But for scientists who lived in Georgia under communism, this has not always been possible.
Researchers were not particularly encouraged to publish in Western journals. Actually, you might end up having a problem if you did publish something in a Western journal.
Research that proves the worth of phage medicine was published by the Georgian scientists, but only in the Soviet Union. And even today, it is ignored because of a strange phenomenon that's true across the world of science. If you don't publish in English, your science barely exists.
Even the best publications, again, they were published either in Russian or in Georgian. Now, not many people in the United Kingdom or in the United States can read in Russian. Probably even less can read in Georgian. So I think the problem here is not because the science was bad, but because they could not read it. They could not, get acquainted with it.
But there is one set of phage experiments that were beautifully designed, carefully conducted and published in English. They were carried out on cows by a maverick veterinary biologist called Willie Smith.
The thing that sparked my interest in using phage was Willie's experimental work, which was absolutely fantastic. The results are brilliant. I mean, nothing about the guy surprised me, really, but it really was very exciting.
Sadly, Willie Smith died in 1987. But his rigorous animal work is the only reason anyone in the West has ever heard of phage therapy. Throughout the phage days, his assistant was Mick Huggins.
I helped him at the time, really as the muscle collecting the casts.
When Smith and Huggins started testing phage in cattle, neither really expected it to work, and their colleagues were even more skeptical.
They thought that there was no future in it because previously a lot of extravagant claims had been made, which was one of the reasons why we did experiments over and over again to make sure that we hopefully weren't going to fall into the same trap. We collected phage from sewage stations, from markets, from slurry pits, where we expected to find bacteria that caused the disease. The idea being that you would most likely find these phages in areas where you got a collection of shit.
By paying scrupulous attention to detail, they performed work that even today is universally respected. They extracted phage from the cow muck and used it to treat calves suffering from lethal diarrhea.
We found that when they were treated with the phage, they did not show signs of diarrhea at all. The clear-up rate was 100%. We found that the phage was better than most of the antibiotics and as good as the best.
With Willie Smith's death, Huggins moved on and the cow work came to an end. But their outstanding work on animals had caught the interest of Paul Barrow, who worked in the lab next door.
I inherited some of Willie Smith's staff and his large collection of bacteria and phages, which he started in 1945 and has now reached over 7,000 cultures. So each of these tiny little vials contains an individual bacterium or bacteriophage preserved, which will maintain for many, many years. And you can see that it's basically impossible to know what is what without consulting our stock book. But they're all there for our use.
Barrow didn't take up research on phage therapy himself until the crisis of antibiotic resistance came to his attention. Today, he and his small team work on resistant infections in animals.
We have been extending the work that Willie Smith did using bacteriophages to control and treat blood poisoning and meningitis into chickens. And the experiments have worked very well. We've been able to both prevent and treat E. coli infections in chickens, and the experiments have worked fantastically, really.
James Soothill was also inspired by Willie Smith. He has since directed his research towards humans and the resistant bacteria which infect burns.
People with large burns get infected with Pseudomonas aeruginosa. It's the biggest cause of death 48 hours after being burned, and it also causes skin grafts to fail. My reason for wanting to work on it in that Pseudomonas aeruginosa is normally resistant to many antibiotics and readily acquires new resistance, so it's one of the bacteria that could be a problem in the future.
Although Soothill and Barrow realized that antibiotic-resistant bacteria could be overcome with phage, they have found it impossible to convince their scientific colleagues, who are still wedded to the idea of antibiotics. Ever since 1947, when resistance began to emerge, the immediate answer to any resistant infection has been, find a new antibiotic.
The individual scientist in the laboratory goes on seeking new germ killers. The industrial chemist continues to develop them and improves production processes. Dr. Waxman's streptomycin has been modified and combined with chemicals to slow down the development of resistance by disease germs.
But there are profound reasons why this approach will never solve the whole problem of resistance. Every time we take an antibiotic or spray one onto a crop, the weakest bacteria are killed. The few strong ones, resistant to the antibiotic, are left to multiply. Resistance is inevitable. And the more antibiotics we use, the worse the problem becomes. This plate of Staphylococcus has been dosed with antibiotics which kill most bacteria. But MRSA, the resistant bacteria, thrive when the sensitive ones die, and they soon take over, in a clear example of survival of the fittest.
This is evolution in action. Essentially, when you use antibiotics, you provide what's called selective pressure. That means that the bacteria which have a gene which allows them to resist the action of the antibiotic are better able to survive when you give a patient antibiotics. And so consequently, within hospitals and also in the community, we have grown up a generation of bacteria which have an increasing ability to fight off our antibiotics.
The key problem with antibiotics is that they are unchanging chemicals. Once bacteria develop resistance to them, they become redundant. But phage is different. The beauty of phage as a medicine is that they are alive, so they can change, just as bacteria do. When bacteria evolve resistance, phage evolve alongside. When a superbug appears, a superphage will always evolve to attack it. It's an evolutionary arms race. Phage offer the world a naturally evolving medicine, able to fight off any new bacteria that emerge.
В отношении фагов тоже, конечно, устойчивость возникает, но не такой частотой. И, во-первых, мы можем новые клоны получить к этим. Если даже они фагоустойчивы к тем фагам, которые у нас в лаборатории, мы можем получить вот этот.
Back in Georgia, when the Institute has sent a sample of antibiotic-resistant bacteria that is also resistant to all their phages, they go back to basics and search for a new virus.
Недавно мы из республиканской больницы получили несколько штаммов, которые оказались устойчивыми к тем коллекциям, которые у нас имеются в лаборатории. Поэтому нужно выделить новые фаги в отношении этих резистентных микробов. А здесь, именно в этой точке, стекает коллектор республиканской больницы. Мы потому сделаем здесь, именно здесь, потому что сточная вода грязная. Там бывают все вот эти микробы, которые циркулируются в настоящее время в республиканской больнице. И там, где микроб, там фаг.
Lurking in this sewage is the superphage that promises to beat the new resistant strain of bacteria from the hospital. Phage could also hold great promise for the rest of the world, but as ever, there's a catch. In 1991, the Soviet Union broke up, and civil war broke out in Georgia. These events combined to threaten the existence of the Institute, and may eventually destroy the precious collection of phage that's held there. Years of power cuts caused by the war mean that already hundreds of phages, carefully stored at just the right temperature in the Institute's refrigerators, have been lost.
In the laboratories we had about +5 degrees, 7 degrees, because it was not heated at all. And we had lights something like 2-3 hours per day. We went moving these phages to home refrigerators or back here, depending on how it is. But in winter it's okay. We were frozen, so the phages were okay.
One hot summer and one too many power failures, and the Institute could lose 60 years accumulated experience. The Soviet money that funded this unique institute through most of its life went when Georgia gained independence. The cost of civil war meant that the Georgian government itself had no money for science. In the last few years, the tiny amount of phage medicine produced here has been made by hand and makes little profit. There has been no money to keep this place going, and research has virtually ground to a halt. There seemed no future for the Institute or its precious medicine. Meanwhile, the outside world remains so ignorant about phage that people like Paul Barrow in England have found it almost impossible to get money to fund their research.
We are in the process of trying to put together grant applications to continue some of this work and expand it, and most of the replies that we've had have been negative.
Just when it looked like the end for phage therapy, something amazing happened. Everything changed when a popular American science magazine published a piece about the Institute, the first article ever written about the place in English. One of the people who read it was multimillionaire Casey Harlington.
When I first saw the article about the Eliab Institute and bacteriophage was when I was flying back from Toronto with my girlfriend Monica, and I was reading a Discover magazine, a new one I just got off the shelf, this one here. And I saw this article on the good virus. Actually, it was the last article that I read in the magazine. It didn't look that interesting to me. Anyway, as I read it, it called out to me to investigate it further.
Casey Harlington is a venture capitalist who made his millions setting up technology deals.
Just in case they run into some problems, but it's got to be U.S. cash. I don't have any science background to speak of at all, other than what I read in popular science journals, which I read regularly for interest. My background is a stockbroker. I've been a stockbroker since I was about 23 years old. And I thought that there'd be profit in phage in as much as there's profit in antibiotics immediately.
After reading the magazine, Casey Harlington made contact with the Institute and decided that phage medicine did have a lucrative future. Within 9 months, he'd raised enough capital to set up a company. The business was based in the USA, but it was called Georgia Research Inc., or GRI. Back in Georgia, GRI opened a small lab in the grounds of the Institute.
This space is leased by the GRI, and the conditions here are much better than in the main building, because it is completely privatized, this building, and the owners managed to have electricity and water running permanently.
The spending hasn't even begun. I mean, we're talking about a pharmaceutical development company, talking, I mean, you can get into the hundreds of millions of dollars in a fairly short period of time, I'm sure.
Fully aware of the problems caused by antibiotic-resistant infections in hospital, Casey's first move was to fund a joint research project between his lab in the Republic of Georgia and Glenn Morris's team in the USA.
Phage therapy is an interesting idea. Will it ever find wide acceptance? I don't know. But I'm in a position where I find myself not able to treat my patients. And under those circumstances, I think it's very reasonable to look back at what we have looked at in the past.
I'm not much of a phage expert, and not too many people in this country being involved in phage studies. We're sending about 500 antibiotic-resistant strains to Georgia. Nino and her colleagues can screen those strains against the phages that they already got in their collection. When they identify a specific phage, they're going to send that phage, hopefully, back to us here in Baltimore.
The 500 samples all came from patients suffering from lethal antibiotic-resistant infections. Before the Georgian team could begin their search for the right phages, they had to regrow the resistant bacteria and confirm exactly what they had been sent. But being familiar with the nature of phage and the way they live on the backs of bacteria, they knew what else might lurk in the samples. And after weeks of careful work, they found it. These plates are striped with the resistant bacteria from Baltimore. On the stripe from patient number 19, they found a clear spot where something was killing the bacteria. They grew it, tested it, and confirmed it was phage. And there were even more phages in other samples.
Here you see how the antibiotic-resistant strains are killed by the phages.
If these phages had been given as medicine in large doses, they might have cured the patients that died in America. The magical viruses might have worked where antibiotics failed. This could be a key new drug for the West. Thrilled by the instant success of the company's first project, Casey Harlington decided to bring scientists from around the world to Georgia to discuss the future of phage. Enthusiasts from England, the USA, Canada, Poland and Germany came together for the world's first international conference on therapeutic phage. The conference was hosted in the mountains above Tbilisi, at what used to be the Communist Party headquarters.
I'm not sure where we are, actually.
We're in the wilderness. We feel like pioneers today.
Broken beds, no flushing toilets, no lights in the washrooms. This has nothing to do with Georgia. Personally, I'm enthralled with Georgia. I really am, and people as well. This just happens to be, the victim of the communist era, that's all. It's no big deal.
The conference was a marvelous chance for the few people in the world obsessed with phage therapy to compare notes.
It's a great opportunity to talk about phage because, normally I talk about phage and everyone doesn't want you to talk about it, but here everybody else wants to talk about it as well, which is great.
But the company scientists were there to sniff out profitable ways to beat antibiotic resistance. They had to assess which research Casey should support and which he could afford to ignore, which skills the company needed to buy and which it could develop for itself.
What I hope to do is draw out all the information I can that will help us get these phage approved by FDA.
And they wanted to judge the Georgian work carefully, because both lives and money were at stake.
Bottom line is we'll all benefit if they are capable of providing what they say they have. If they don't have what they say they have, then we will be the big losers and they will be the big winners because they're getting everything that they say they need to refurbish their facilities and pay scientists and researchers, etc. So it's a big gamble for us. They've got everything to gain and nothing to lose.
Будем совместно разрабатывать препараты до получения патентов. Значит, то, чтобы довести его до возможности использования и выпуска. А дальше, кто будет выпускать, как будет выпускать, это будет уже дальнейший разговор между институтом и этим.
Company president is Richard Honor, a scientist, businessman, and realist.
They have a distinct role, and we have a distinct role. Their role, their accomplishments have been in the area of discovery and invention. Now our role, which is quite distinct, is to bring them forward as Western quality, Western standard pharmaceuticals. That makes this marriage a perfect marriage. Yeah.
Whether this really was a perfect marriage remained to be seen. But everyone came together with high hopes. The Institute was pinning its hopes of survival on the company. The businessmen were looking for products and profits.
What's he saying?
There will be big financial gains for some if phage medicine spreads beyond Georgia. But the stakes are higher than that. With antibiotic resistance on the increase, the future of modern medicine may depend on bringing phage therapy to the rest of the world.
The net result of this collaboration is going to be the ultimate development of real pharmaceutical products that will withstand the scrutiny of a regulatory environment any place in the world.
The problem of antibiotic resistance grows worse every day, everywhere. But making phage medicine for use in the West would involve a huge amount of work. Years of medical trials that were carried out at the Institute would have to be repeated to the standards of the American Food and Drug Administration, the all-seeing, all-knowing FDA. It's doubtful that these vats would ever be acceptable to the FDA. So Casey Harlington plans to produce his phage elsewhere. Back in America, the company has already started building a large pilot production facility on the outskirts of Seattle.
What we're going to do with this very large space is build it into a phage therapeutics development laboratory and manufacturing facility. The next step in the process is to go to scale-up pilot manufacturing, which will also be FDA certifiable for human use therapeutic products using this phage technology.
How many employees?
All of this
FDA certifiable proof that phage can help fight antibiotic-resistant disease is still many years and many millions of dollars away. But Casey and the company were firmly convinced by what they saw in Georgia.
Well, when we moved into this space 1 month ago, we signed a 15-year lease to make sure that we could see multiple products through to market from the beginning stages.
Каждая фирма старается для себя все сделать. Одна единственная проблема – это проблема существования. Мы должны выжить.
I guess it's a matter of who gets there first and who dominate the market.
I'm absolutely sure that he is good for the Institute because he has very good, very pure intentions. Nothing is hidden behind. Everything is said clearly.
It's a technology, basically. It's a biological technology. It's just business.